I'm going to be reviewing Cluster 2 of the Jan 2026 Regents exam for Earth and Space Sciences. In the last video, I did Cluster 1. I'm going to continue with the same exam and do the next cluster. I'll start by highlighting and getting out all the important information. Rubber ducks and Pacific Ocean trash. On Jan 10, 1992, the container ship Ever Laurel lost 12 40-foot containers during a storm at sea. One container broke open and released over 28,000 plastic bath toys. Highlighting numbers is good. These bath toys floated on the ocean surface for years and made landfall on beaches worldwide. The Pacific Ocean is home to the GPGP. The island of the plastic is 1.6 million square kilometers in size. That's huge. Garbage patches are found worldwide within ocean gyres where water conditions are calm. This is what allows the plastic to accumulate, so that's a very important fact. Scientists have been studying the sizes, compositions, and ages of plastic pieces in the past to determine the origin of the plastic in order to mitigate the problem of plastic pollution in ocean ecosystems. Alright, so there's a lot of background in that and not a lot of information. So this is probably more of a knowledge question. So if we look at this map, that's the patch, and it's accumulating here. So what I'm immediately going to do is I'm going to go to page 20 of the reference table, because this is where all the currents are. Yeah, so you're going to have to tilt your head sideways to see this page, because there's nothing I can do. Alright, our first question. Complete each of the three statements below by placing an X to correctly describe the factor responsible for global atmospheric and ocean circulation patterns that distributed the bath toys to various locations on Earth. Evidence for the distribution pattern of the plastic bath toys from the accident location to the northwest coast of North America is provided by the movement of toys along the Kuroshio current. Let's look in the reference table. I'm going to mark this up too. Okay, we can see that the Kuroshio current is over here, and it's not really close to northwestern North America, so that's wrong, and this is our answer. And to prove that, it's going to get pushed by the North Pacific current over here, and then it's going to take the Alaska current and then swirl around and then become calm and then form the garbage patch. So this is our answer. One cause of global circulation patterns of the ocean currents is, okay, come on, even if you guys are stupid, you guys would know this one, because that has nothing to do with anything. The way that the continents are has a huge impact on the accumulation of garbage, so that's our answer. Pretty easy. Other than the ocean currents, global patterns that contributed to the distribution of the toys were also influenced by atmospheric density, yes, density of the circulation, and heat energy differences. Yes, the greenhouse gases are impactful to other scientific things, so that's wrong, and this is our answer. That was a pretty easy question. Other than ocean currents, which other factor determines the global circulation of these plastic toys? Nothing to do. Yeah, it's too easy. The winds will just move the water, and it will circulate the plastic. Many types of plastic are found in the Earth's oceans. The pie charts and infographic below show some information about plastic in Earth's oceans. Okay. So here's all this stuff that's in the ocean. It's bigger than 5 centimeters. And it's showing the transfer of plastics through biology. Like, the plankton are eating the microplastics. The fish are eating them. The larger fishes are eating them. And the birds end up eating them, and they feed on the surface, so this harms the food chain. So let me just highlight some of this stuff. Plankton ingest, bioaccumulation, feed directly on surface. And they turn into microplastics, so it's hard to see. So sea turtles in the GPGP often feed on plastic bags and plastic sheets. This is because the turtles mistake the plastic for the common prey jellyfish. Which statement explains how the removal of plastic bags in the GPGP will stabilize biodiversity in the area? So decreasing the number of bags in the GPGP will cause the jellyfish population increase. Well, it's wrong because since turtles will stop eating the plastic, there will be more turtles to eat more jellyfish, so their population will decrease actually. So that could be right. Decreasing the number of bags in the GPGP will cause the turtle population to increase because the turtles will eat more jellyfish. It's a backward sentence, that's wrong. Decreasing the number of bags in the GPGP will cause the jellyfish population to decrease because the turtles will eat less jellyfish. No, that's just as bad as number 2. Decreasing the number of bags in the GPGP will cause the turtle population to decrease because the turtles will eat less jellyfish. That scientifically doesn't make sense, so my answer is 1 for 8. Oh, shoot, hold on. Wait, it's 1 that is wrong here. And it's actually 2. My bad, guys. It's 2 because it will cause the turtle population to increase because there's less plastic, and the turtles will eat more jellyfish. Yeah. That makes sense. What the hell? So much reading. Many organizations and governmental bodies have investigated methods to address the growing population of plastic pollution. These methods include reducing the use of plastics, recycling plastics, and participating in waterway cleanups. Many complex solutions are being used to clean up rivers and oceans, and rivers barriers at the mouth of the river funnel the plastic into a collection area where the plastic is manually removed and hauled away to be recycled. In ocean, scientists use a device to collect floating plastic and bring it back to the shore for recycling. The photograph and model below show how some information about these 2 removal methods. So it's just going to trap the trash and the barrier, and then the collection is going to suck it all inside there. So it aims to collect. It's the artificial coastline. It's driven by wind waves. So if marine life is trapped, it will allow them to pass underneath. A support vessel will collect any debris. Now let's look at oh my god, so much reading, guys. Let's look at the question first. A student makes the claim that the river cleanup method is a more effective design solution than the ocean cleanup method for reducing the impact of plastic pollution. Using all the information provided, which statement provides the most direct evidence to support the claim? The river method costs less than the ocean. Yeah, it does. Because it captures plastic before it enters the ocean. Yep. Protecting river and coastline biodiversity. That could be right. That is the answer, probably, but I'll check the others. The river method can collect plastic over a larger area. Well, that's what the ocean does, so that's wrong. Yeah, that's wrong. The river method is able to capture plastics of all sizes. No, not all sizes, because it can't do that, so that's wrong. And the river method captures more plastic than the ocean, because more plastics are found in the ocean than in rivers. Okay, that's just wrong, so 1 is our answer for 9. Alright, that's the end of cluster 2. I'll do cluster 3 in a future video.